So in our setup, in this part of lesson 5.5 today, we're going to write and graph a linear inequality into variables. In other words, we have to set up our own linear inequality to represent a situation. Okay? And we know that whenever we set up our own equation or equations to represent a problem, the first thing we always do is what? There's going to be variables in it. What are we going to do? Identify what you're standing in for. What's that X representing and what's that Y representing? We say that first. Some of you lost points on the quiz because you just refused to do that. I don't really know why, but but instead of an equation today, we're going to be setting up an inequality. Okay? So we have our problem here. It says the royalties for a high school play are $400. What does the royalties mean? We're talking about king and queen or what? The royalties for a high school play are $400. Jacob?
Royalties are payments made to like somebody who originally made something.
Yeah.
So like if you use it for a high school play, then you would have to pay the person who made those things.
Yeah. So the person who wrote that play and is now letting other people put it on, you have to, so when those productions are put on here, they're paying a royalty fee to be able to use that particular production. So that's money that's going to have to be paid up. Okay? Tickets to the play sell for $5 for students and $8 for adults. What are the possible combinations of ticket sales needed to pay the royalties? Do you think we can begin to list them all? No. And we should be, after we did that assignment for today when we didn't know what the linear inequality was representing, we should now be well aware of that there are how many solutions to a linear inequality? There's an infinite number of them. They all come from the shaded region and the solid boundary line, if there's a solid boundary line, right? Okay, so in this situation, it says, what are the possible combinations of ticket sales needed to pay for the royalties? What does it sound like maybe X and Y could represent?
The number of student tickets and the number of adult tickets.
Yeah. We know how much they are per ticket, but we don't know how many we need to sell, right? So we could let X represent, let X be the number of student tickets. And we can't, we want to be specific. So we're talking about how many student tickets are needed to be sold. And then Y can be the number of adult tickets, right? So it isn't the price. We already know that. We just don't know how many people need to buy tickets to help us pay these royalty fees. Well, and then the other important piece of information that they gave us is they need to make at least how much money to be able to, pay those royalties. $400, okay? So need to make $400. Now we could make this into an equation, but we're going to make it into a linear inequality to show, you know what? They aren't going to just stop selling tickets probably when they get to the $400 mark, are they? No. They'll be happy to sell more tickets even after that, because then they would do what? Make a profit. Yeah, they make a profit after that. So we have let's set up our linear inequality then with that information that we were given along with kind of what we've defined here. Anybody think they would have an idea of what linear inequality we could set up? Jared?
X plus 8y is less than or equal to, or is greater than or equal to 400.
Okay. So $5 for every student ticket. So how much money would be taken in student tickets would come from multiplying X by 5. That would say, okay, here's how many dollars you take in with student tickets. And then plus the 8 times the number of adult tickets, because the adult tickets are $8 a piece. We don't know how many we're going to sell. Is greater than 400. What's that part we just talked about? That would be when we're making a profit, right? What's the equal to part? Yeah, just being able to pay just the royalties, right? Paying that royalty fee. Okay, So here's our linear inequality. So we need to do what with it so we can get our boundary line? Yeah, we need it in slope-intercept form, don't we? Okay, so what can we do first here?
Subtract 5x.
Okay, let's subtract 5x from both sides. Now I'm going to change that to add the opposite. I'm going to make it plus a negative 5x. And then, what are we going to do? Divide by 8. Okay, every piece has to be divided by 8. I got some people who are still just doing whichever ones they feel like. The ones that maybe are convenient to divide by, I'm not really sure how the decision's getting made, but when we multiply or divide, it has to be to every piece of it. Did we divide by a negative? No. So we don't need to switch the symbol. So we have y is greater than or equal to 50 plus negative 5/8 x. Okay. So let's identify our slope and y-intercept to help us. Well, since it's in that form, let's start with the y-intercept. What's our y-intercept? 50. And what's our slope? Negative 5/8. Okay. Well, I got the coordinate plane set up for us already. I even put titles on the axes for you. How nice of me. A good thing that we went with student tickets being X, it looks like, and the adult tickets being Y. Okay, so don't even worry about answering this stuff over here. We're just going to graph this right now. So first thing you need to do is you need to get your axes numbered out. So what's the scale I picked? And actually, I think it's the same on both of them. What is the actual scale? It's going by 5s, isn't it? Yeah. So get that numbered. I'm walking on my own feet, not yours. Okay. Okay, so where do we start? 50 on what? On the y-axis. Okay, so we're going to go for the point at 50 on the y-axis. That's our starting point. Now, remember, we do negative 5/8 means we need to do what? Go down 5 and write 8. Okay, now, how do you feel about that? Is the scale 1s? Okay. 5's okay, that works, but the 8 isn't so should we change those to being both multiples of 5? Sure. Rename it. Okay, so we'll multiply both of them by 5. And we will then have a friendlier name for our slope to work with. And now we say, okay, I need to go down 25, which is not 25 with grid lines, but so we say 5, 10, 15, 25. We got to count by 5s, don't we? And then we go over 40. 5, 10, 15, 25, 35, 40, and we put another point. And then we do it again. 1, 2, 3, 4, 5. That's 25. 5, 10, 15, 25, 35, 40, and I end up down on the x-axis. Okay, and how do you feel about, do we need to extend this line outside of quadrant 1? Why not?
Because you can't have a negative amount.
Yeah, if we extend it up into quadrant 2, we're talking about having a negative number of student tickets. If we extend it down into quadrant 4, then we're talking about having a negative number of adult tickets. Really can't have that. So in reality, we should just connect the y-intercept and the x-intercept and call it good. Should it be dashed or should it be solid? I forgot to ask myself that question. It should be solid because why? The equal to bar is there, that's right. Okay, and now where should we shade? Remember it ended up y is greater than or equal to, the equal to part we've taken care of with the solid line. We shade above or below?
Above.
We should shade above, shouldn't we? Yeah. I haven't played around to see what I could use. Oopsie. Yeah. Okay, now we're finally maybe ready to answer the question. Or actually, we have answered the question. What are the possible combinations of ticket sales needed to pay for the royalties? We've started to answer that by showing our graph. But what do you think? Do you think every ordered pair in that shaded region would be a possibility? Really? So you can you sell, let's see, can you sell 90 and a half student tickets? Is that going in there? 90 and a half, zero? Isn't that going in there? Can't sell half of the ticket or a third of the ticket. So in reality, even though this is shaded, it shows that every point would be, we have to say to ourselves, no, reasonably, only integer values for X and integer values for Y would actually count, right? You can't have parts of tickets. So give a possible combination that would only cover the royalties. Give a possible combination that would only cover the royalties. Jacob.
40-25.
40-25. And where's that point at on the graph? Is it on the boundary line or is it in the shaded region? It's on the boundary line. Jacob just gave us this one right here, didn't he? Okay. So why would that only cover the royalties? What does that line represent?
That they would need to make.
It's actually representing, if we had made this set equal to 400, we hadn't made it into an inequality. If we had made this into an equation problem, we would have graphed only a line, and we would have said that line represents all the possible combinations of making $400. So that, anything on that line, that an integer X value and an integer Y value should give us exactly $400 for royalties. Let's see if it does. Let's do some math here. Some arithmetic, I mean. 440 is the X value. That's the student tickets. How much do the students pay?
200.
They paid $5, so they would take in 40 times 5. They would take in $200 for the ticket sales for the students. And then the adult tickets are $8, and we said there's 25 of those, so 25 times 8? 200. What's 200 plus 200? 400. It works, doesn't it? So that would just, if they sold 40 student tickets and 25 adult tickets, they would take in exactly $400, correct? Okay. Think you know another one? We're not going to write it down, but we could, well, we got to put this part that I hadn't written yet. 40 student tickets, 25 adult tickets. Give me another one. 6510. Okay, 6510. It looks like there might be a point right there. Let's check it out, see if it works. What's 65 times 5?
325.
325. What is 10 times 8? 80. What's 325 plus 80? 405. So even though it looks like it's going through ordered pair 6510, is it? No, because it gives us a little bit more than $400, doesn't it? But we know 3 of them for sure. We know 3 of them for sure because we use 3 points to graph the line. Wouldn't this one work also? Don't sell any student tickets. For some reason, the students don't go to the play, but just the adults do. Or how about this one? Only students go to the play, but no adults do? Yeah. Okay, now, let's answer this question. What do the combinations in the shaded region provide? What's that telling us in this problem?
That's how much they would make that wouldn't pay the royalties.
In the shaded region?
No,
Oh, yeah. The shaded region would show us, they'd be able to pay the $400 and make some profit, right? So let's write that down. They would have enough to pay the royalties. I didn't leave us a whole lot of room to do this, did I? Royalties, just royal, put T-I-E-S on it, and make a profit. So in reality, you could say, you're going to make a profit, okay? Yeah. Profit means you pay for all your expenses and you still have some money left. So it means we're spelling it out a little bit more. Okay, what are the combinations in the unshaded region provided then? What do they say? If you sell any combination of tickets in the unshaded region on that graph, such as, what if they sold 40 student tickets and 20 adult tickets? They wouldn't cover the $400, would it? Yeah, they would lose money, wouldn't they? So we're going to say, for that one, they would not have enough to pay the royalties. There would be loss. They go home. They begging somebody else to give them some money. Okay, so you're going to have some application problems with these linear inequalities also. Any questions or concerns at the time? No? Okay. Then let's go to the back side and let's look at the other skill we're going to be asked to do today. Write an inequality in two variables to represent the graph. I say here's a good plan of attack. Number one. Read that together with me, class. Oh, wait a minute, it's not just Jared. Everybody, number one, together. 1, 2, 3.
Determine the slope and y-intercept of the boundary lines.
Oh, okay. Can we do that from a line? Okay. And then number 2, now we have to decide what kind of inequality symbol to use, and we have 2 things to look for. Is the line solid or dashed? So in other words, should it have the equal to bar or not? Is it shaded above or is it shaded below? Okay. So, number 1. Might be easiest to decide where is it crossing the y-axis first. Let's put a point there. Where is it crossing the y-axis at? Does it appear? At 1. Okay, right there. So put a point there. And we're going to say b equals 1. Well, let's find another place on the graph where that boundary line is crossing that it would have integer x and y values. So how are you feeling about maybe this one right here? Anybody think that looks like a good spot? Okay, so then we can find the slope between those 2 lines. The line is rising, so should we have a positive slope or a negative slope? Positive slope. Okay, so I'm going to start at the bottom point and I'm going to count up 1, 2, 3, up and 1 to the right. So the slope is 3 over 1, which is also known as 3. And then we get a positive slope. Okay, so now we've decided, okay, here's what's going in for M and what's going in for B, because really what you're going to do is you're going to have something and we don't know what the inequality symbol is going to be, but we're still going to use this format, slope-intercept form. We're still going to plug into that. So do we have a dashed line or a solid line? Dashed. Which tells us what again?
It doesn't have the equal symbol.
No equal to bar in our inequality symbol then. And it is shaded above or below?
Below.
This is one of those kind of tricky ones. It's so steep, it's kind of hard to tell. So here's what I do when I can't make that decision. I take that line and I kind of like flatten it out a little bit, going the direction that it is. I say, you know what, I'm just going to flatten it out a little bit more. Is it shaded above or below? It's shaded below, isn't it? So then, if it is shaded below, that tells me that, and it's dashed, that gives me some pretty, so that tells me what kind of inequality symbol I need. Which one? Is less than. So step one, find some information out about the boundary line, the slope of the y-intercept. Step two, we're looking for the inequality symbol. So we have to decide, do we have a dashed boundary line or a solid? And was it shaded above or was it shaded below? And now we're ready to write our inequality statement that represents this graph. Y is less than 3x plus 1. So in other words, if this would have been one of your problems for today, to graph this inequality, it should have turned out looking like what we have there. Okay, how about you try the next one on your own then? Try the next one on your own. Let's remember step one, you need to find the slope and the y-intercept. The line is falling from left to right. What important piece of information does that give me? Slope is negative. Okay. Who wants to offer up a visual slope of these lines? That? A rise of 3 and a run of -2. Okay? How many of you want to agree with Todd that we could have, or maybe you have a rise of -3 and a run of +2? I did the same thing, really? Because we're saying that our slope is what? -3/2, right? You take that, pull that negative out, we end up with a negative slope. What's our y-intercept? 4. Okay, so we know that we have a m value of -3/2, we have a b value of 4. I decided it was a solid line, am I right? Okay. Where's it shaded, above or below? Below. And again, if you can't tell, that's kind of hard for you to tell, you just flatten it, going the same direction that it is, you just flatten it out and say, okay, oh, I think that's shaded, and you gotta pretend all that shading went with it, of course. It is shaded below. Well, then that tells me I need which inequality symbol? Is less than or equal to, right? Because the solid line is the equal to part. Okay, write down an inequality statement and talk to your table partners, see if you guys agree. We're on number 2. That's the one we're doing. No, it shouldn't be anywhere else at the moment. Okay, what's it going to be? What are we going to say the inequality, linear inequality is for this one? Courtney?
Triangles figure 3/2 x plus 4.
Equals?
Less than.
Is less than or equal to -3/2 x plus 4. There we go. There's our linear inequality that graph is the solution for. Okay. One more. So again, we always want to start with the boundary line. What do we want? What decisions are we going to make? It's rising from left to right. That tells me I better have kind of slope. Those are the thoughts that should be going through your head. Anybody agree with me that the slope of this line is 1/2? The y-intercept is -2? Yeah, okay. Do we have a solid or a dashed line? Solid, which tells us what again? Equal to, so we have a solid line, and it is shaded where, above or below? This time it's shaded above. Okay, shaded above. So what kind of inequality symbol would that be, Abby? Greater than, is greater than or equal to. Okay. Let's talk about the inequality, linear inequality that this graph is a solution for. Aaron?
Y is greater than or equal to 1 plus
Okay. How would we see that in an answer bank, do you suppose? Todd? Not equals. Yeah, this is probably how we would see it in an answer bank, though, wouldn't we? Yeah, okay. So, what if this was, I had a problem like this on the quiz, and it was worth 10 points. You get it right or you get it wrong. 10 points. So it's a 40-point quiz, and just this problem alone is worth 10 points. It can bring your grade down to 75% if you don't get it right. What do you think you could do? What do you think you could do to help guarantee that you did a fairly good job and you're feeling pretty confident about earning that 10 points? What's one thing you think you could do?
Check problem.
You could do a check problem. How would that check problem work?
You pick a point from the shaded area and you substitute it for x and y.
Okay.
So that inequality is true.
And what would we be testing there? If we picked a point, this is what Todd said. He says pick a point from the shaded region, substitute it in, see if it makes it true. What are we actually testing there? We are testing in order. We are checking it with an ordered pair, but we're testing to see if we have the inequality symbol correct, aren't we? Is greater than or is less than? And then, how do we know if we have the right slope and y-intercept? What do you think we could do there? Elena? We could graph it. Or what's another thing we could do? They've already got the graph there for us in reality, so could we test a point from that line? Pretending this is an equation? Remember before we did any shading? If we wanted to make sure that that was the correct line for an equation, any point on it had to make the equation true, did it not? Okay, so here's what would happen if we tested a point from the line. And we're going to do one really quick just so I can show you what that looks like. Give me a point that's on this line that has integer values. And I don't care which one it is. You pick one that has integer values that would make our life. And the other thing I think I might like is that since I'm going to have to multiply by a half, I want the x value to be an even number. It's 2 - 1 right here. Okay? So if we test 2 - 1, what we're really saying then is we put -1 in for our y is greater than or equal to 1/2 times 2, and then plus that -2 or subtract 2. So -1 is greater than or equal to 1 plus -2. What is 1 plus -2? -1. And notice which part of the inequality statement does it make it? What part of this says, okay, this is why it's true? The equal to part, and that's the part it should, because it's on the line. And if we tested one from the shaded region, then we better end up with something like, I don't know, maybe end up with -1 is greater than -6. Something else that's true. So again, there are ways for us to check to see if we did a good job or not.